All right, this is part 2 of the fundamental theorem of algebra, section 2.5, where we're going to expand on what we did yesterday. So we're going to talk about some new terms when we are writing our polynomials in factored form. So if we write a polynomial that is a product of factors that are irreducible over the rationals, okay, that means that we can't write it as any more factors that have rational solutions. Remember, rationals are fractions. But when we talk about rational numbers as fractions, we have to remember that the number 2 is a rational number. 2 over 1 is a fraction. We just reduce that to 2, but it is a rational number. Then we can write it as a product of linear and quadratic factors that are irreducible over the reals. So reals numbers are the rational ones that we just talked about, and irrational. So irrational would be like the square root of 2, the square root of 5. Any square root essentially is an irrational number because we can't write it as a fraction. And then if we talk about completely factored form, okay, completely factored form, that talks about that's the real zeros and the complex zeros. Real and complex. So if we look up here at the stuff we did yesterday, how we have our linear factors right here, and some of our linear factors have a square root of them. Those would be irrational zeros. And these that have imaginary or an I in it, those would be complex zeros. So what we did yesterday, this right here, that is a factored form that is irreducible over the rationals because we have our two factors, x minus 2, x plus, that have rational solutions, but x squared plus 4 does not have a rational solution, so we can't factor that any further and get a rational zero. And then we wrote it in completely factored form right here. And that completely factored form has all linear factors with either real, irrational, or complex zeros. We had 2 real and 2 complex zeros for that one. So that would be in completely factored form. So as we look at the problem that we're doing today, we're going to get, as we're getting to completely factored form with the real and complex linear factors, we are going to eventually get to the irreducible over the rationals and irreducible over the reals on our way to the completely factored form. So example 1 says we have x to the 4th minus x to the 3rd minus x squared plus 5x minus 20, and one factor is x squared minus 5. So we have two choices here. We could do the rational zero test and do factors of 20 over the factors of 1 plus or minus and do synthetic division. But if our zeros are not rational, we're never going to find those zeros. So that is a drawback of that. So if we divide x squared minus 5, but I'm also going to put plus 0x as a placeholder to make things a little bit easier. And then we have x to the 4th minus x to the 3rd minus x squared plus 5x minus 20. So I'm going to divide this, and I should get a remainder of 0. And then whatever my quotient is up above, I can see if I can factor that or quadratic formula, depending on what we are left with. So x squared goes into the x to the 4th, x squared times. So x squared times x squared is x to the 4th. X squared times 0x is 0x to the 3rd. x squared times negative 5 is negative 5x squared. And then we will subtract. I just want to make this a little bit neater. X to the fourth minus x to the fourth is 0 x to the fourth. Negative x to the third minus 0 x to the third. I know that looks like 10, but no, it's minus 0 x to the third. That gives me negative x to the third. Negative x squared minus negative 5x to the squared is 4x squared. And then I'm bringing down 5x minus 20. X squared goes into x to the third. Negative x to the third, negative x times. Negative x times x squared is negative x to the third. Negative x times 0 is 0x squared, or minus 0, it doesn't matter. Negative x times negative 5 is negative 5x. So then we will subtract. Negative x to the third minus negative x to the third is 0. 4x squared minus 0x squared is 4x squared. 5x minus negative 5x. I'm sorry, this should be a plus right here because negative x times negative 5 is plus. So 5x minus 5x is 0. And then we bring down the negative 20. And then how many times does x squared go into 4? Positive 4 times. And hopefully this will give us 0 as a remainder. And it does. So that tells us that x squared minus x plus 4 is a factor. So I'm just going to write that here, x squared minus x plus 4. Now, can we factor that? No, there are no two numbers that multiply to positive 4 but add to negative 1. So what that tells us is that part A, irreducible over the rationals, that part A, where do I want to write this? So part A of this problem would be f of x equals the x squared plus 5 that, x squared minus 5 that we were given, and the x squared minus x plus 4 that we calculated. Oops, minus x. Because that does not, these two factors, we can't factor this any further and get rational zeros. All right, so now for letter B, it says a product of linear and quadratic factors are irreducible over the real. So I could have rational or irrational numbers. Well, I want to figure out what are my solutions to this. If they are complex, then for part B, I just leave that alone. So let's do the quadratic formula for that. Let's see if I can find some space. So x equals negative b plus or minus, let's just start plugging negative 1 plus or minus b squared square root of negative 1 squared minus 4 times 1 times c, which is 12, all over 2 times 1. So if we type that into our calculator, we get positive 1 plus or minus the square root of negative 15 all over negative 15 all over 2. So that can be rewritten as 1 half plus square root of 15 over 2i and 1 minus 1 half minus square root of 15i over 2. So x equals 1 half plus the square root of 15i over 2 and 1 minus the square root of 15. Whoops. X equals 1 minus, no, these are both over 2. So those are complex zeros, they're not real. So that means part B would be f of x equals, well, the x squared minus 5 from part A, that has a solution, or can be factored into x minus the square root of 5 times x plus the square root of 5, because remember, our difference of two squares formula says if I have a subtraction sign here, I can take the square root of the first term, which is x, and the square root of the last term, which is 5, and that would be my parenthesis. Those would go in my parentheses there. Okay, so that would be that part, and then I would have to recopy down the x squared minus x plus 4, since that cannot be reduced to a rational zero. All right, then letter C is when we're going to write it all out as linear factors. So we have x minus the square root of 5 times x plus the square root of 5, and then we have to do the imaginary or complex zeros. So x minus 1/2 plus square root of 15 over 2i, and then x minus 1/2 minus the square root of 15 over 2i. So that would be my completely factored form with our irrational and complex zeros. Right, now for example B, and then example 2, A and B, we're just going to find the zeros. We're not going to do all these steps right here for them because it can be time consuming. So we have x to the fourth plus 7x squared plus 12. You can factor this in quadratic form as x squared plus 3, x squared plus 4. So now both of these cannot be factored any further using rational numbers. So if you were asked to write it as something as irreducible over the rationals, this would be your answer. And then we're going to set both of these equal to 0. X squared plus 3 equals 0. X squared plus 4 equals 0. Minus 3 from both sides. X squared equals negative 3. And then when we square root both sides, we get x equals plus or minus the square root of 3i. And then here, x squared equals negative 4. X equals plus or minus 2. Oops, I forgot the plus or minus 2i. So if you were asked to write this as in completely factored form, I know I said we're not going to do each smaller step, but I do want to make sure we know what the factored form would look like. Completely factored form would be, x minus the square root of 3i, x plus the square root of 3i. Oops, I needs to be outside the radical. X plus 2i, x minus 2i. So that's completely factored form. All right, the next page, we're given that as one of the zeros is 2i. That also means that another zero, okay, that means negative 2i is also a 0. So that gives us options. We could do synthetic division with 2i, but it gets really ugly. So we probably don't want to do that. We could say, okay, x equals plus or minus 2i. And then we square both sides. We say x squared equals 4i squared. X squared equals negative 4. And then when we add to both sides, add 4 to both sides, x squared plus 4 equals 0, means that x plus 4 is a factor, and we could long divide like we did up here, and it might be a little bit easier. Or we could do the rational zero test, plus or minus the factors of 4 over the factors of 2, that would only give us 8 possible zeros. So you have whatever option you would like, but again, with the rational zero test, if you don't have rational zeros, you're not going to find them doing that. So I would probably lean towards long division, but since we already did one like that, I will do the rational zero test for this one. So we have plus or minus the factors of 4, 1, 2, 4, or the factors of 2, 1, and 2. So 1 over 1 is 1, 1 over 2 is 1/2, 2 over 2 is 1, we already got that, but 2 over 1 is 2, and 4 over 1 is 4. So we only have 8 possible zeros, so it won't take us long to test them and hopefully find one. And then after that, hopefully we can factor. So let's start with 1. So then we have 2, -1, 7, -4, -4. 2 times 1 is 2. -1 plus 2 is 1. Oops, 1. 1 times 1 is 1. Then 8. 8 times 1 is 8. And we add that, we get 4. 4 times 4, and then we get 0. Okay, so we do have x equals 1 as a 0. All right, so then we are left with, we have x minus 1 as a factor, and then we have 2x to the third plus x squared plus 8x plus 4. And then we can factor by grouping, factor out a 2, or sorry, we can't factor out a 2x, so we're going to factor out just an x squared, and we're left with 2x plus 1. And then here we can factor out just a 4. So then we're left with 2x plus 1 there as well. So then we have x minus 1 times x squared plus 4 times 2x plus 1. So our solutions, we already know, we've already taken care of this part right here, because that gave us plus or minus 2i. We also took care of this by synthetic division. So our zeros are going to be x equals 1 plus or minus 2i, and then this last one here is going to be -1/2. So those would be our solutions. Right, letter B. So for this one, it might be a little bit of a stretch to do the rational zero theorem, because we have 8 factors of 8 divided by factors of 3. That'd be a lot of them to try to figure out. But again, because 1 minus 3i is a 0, 1 plus square root of 3i is a 0. So how did we get that? We got x equals 1 plus or minus the square root of 3i. Subtract 1 from both sides. X minus 1 equals plus or minus square root of 3i. And then when we square both sides, the left side is going to become x squared minus 2x plus 1. And the right side is going to be 3i squared, which will give us -3. So then we add to both sides. X squared minus 2x plus 4 equals 0. So let's do long division with that. And the nice thing about doing long division with this one, because we are dividing by an x squared into an x to the third, it's not going to take very many steps. So x squared minus 2x plus 4. And remember, the directions said find the zeros. We're also going to write it in factored form like we did up here, but I'll write it in like completely factored form for this one, just so we have more practice with that. But there's only one more 0 we're looking for, which is another reason against synthetic division, because we have so many that are possible, but only one of them would work. Okay, so then how many times does x squared go into 3x to the third? That's 3x. 3x times x squared is 3x to the third. 3x times negative 2 is negative 6x squared. 3x times 4 is 12x. Subtract. We get 0. Then we get negative 4x minus negative 6x. That gives us 2x squared. 8x minus 12x is negative 4x. And then we bring down the 8. And then x squared goes into 2x 2 times. So then we multiply 2 times x squared. We get 2x squared. 2 times negative 2x is negative 4x. And 2 times 4 is 8. So then we subtract, and everything matches up, so we get 0. All right, so our completely factored form would be 3x plus 2. And then x minus 1 minus the square root of 3i. X minus 1 plus the square root of 3i. And then our zeros, well, we already have, like I said, we already have 2 of them. X equals 1 plus or minus the square root of 3i. And what makes this 0? Negative 2 over 3. So today we just added a little bit more complexity to these problems, but we're still at the end of it just finding all of the zeros and then making some pit stops along the way to write them as, completely factored form or irreducible over the reals and stuff like that. So thanks for watching. Make sure to like the video and subscribe.